Does temperature affect the respiration rate of organisms? How does the respiration of dormant seeds compare to the respiration of germinating seeds? This is respiration of germinating seeds. Organisms like plants that make their own food are super important because without them, matter and energy would not be available to consumers like you and me. Take a minute to think about how seeds become plants. If plants need sunlight to grow, how do seeds grow if they are buried in the ground? Look at a seed. Is it alive? Is it dead? Or is it asleep or dormant? How do you wake up a dormant seed? Why do seeds generally wake up in spring and not during winter? Do seeds move matter and energy through the ecosystem like the plants they become? Think about how phenomenal seeds really are as you complete this investigation. I've already calibrated my carbon dioxide sensor. I have a sample of 50 dry or dormant seeds. They came out of a bag. This is 50 germinating seeds. I soaked these in tap water overnight. There's also 50 seeds in here, and these are at room temperature. I've got 50 seeds chilling in some ice water here. These are also germinating initially at room temperature, but now they're close to 0 degrees Celsius. So each sample has, I took the mass of each sample. So this dry sample has a mass of 20.30 grams. The soaked sample has 43.01 grams, and the chilled sample is 42.51 grams. So if you're normalizing the respiration rate, once you get to the analysis, you will need these masses. So when you put the sample in the container, make sure that nothing's touching the probe, and there's no, when we get to the wet samples, that there's no water touching that sensor. Okay, I'm going to place the dry seeds into the container. And I'm going to run the experiment sideways like this because carbon dioxide is heavier than air. And this way we get the maximum measurement of CO2. Before data collection begins, take a minute to think and predict how dormant seeds will affect the amount of carbon dioxide in the bottle compared to an empty bottle. Pause the video here and resume playback when you're done making your prediction. I'm going to start collecting data. I've got to make sure that I don't disturb the system during data collection. I'll be collecting data for 5 minutes, but we will fast forward through data collection for you. Use SparkView tools to find initial and final carbon dioxide concentration and record the results. This is the coordinate tool. When I put a coordinate tool, I can grab the gray box and move it to any point that I want. I'm going to erase it by hitting the X. Also record the time elapsed for the trial, which you can find here. Remove the seeds from the sampling bottle. One way to remove excess carbon dioxide from the bottle is to wave it in the air a few times like this. For the next run, we will repeat the procedure with room temperature germinating seeds, but first, make a prediction of how germinating room temperature seeds will affect the amount of carbon dioxide in the bottle. Pause the video here and resume playback when you're ready. Let's add about 25 milliliters of room temperature germinating seeds. The mass of this sample is 43.01 grams. Carefully add the sensor and keep it from getting wet. Now we will collect data for 5 minutes. Record initial and final carbon dioxide concentrations and time elapsed as before. Notice how run 2 is checked. in this run legend. I can go back to run 1 if I need to by moving the check mark to that run. But when you use any of the SparkView tools, make sure the red box is on the run that you're interested in. Tools only work on the run that has the red box around it. Let's take a second to remove excess carbon dioxide from the bottle. Now, what would you do if you were asked to design an experiment where you had to change one variable and see how the carbon dioxide produced will change? Well, let's look at changing the temperature of germinating seeds. For the final run, we'll repeat the procedure with germinating seeds that have been chilled in ice water. Make a prediction of how germinating chilled seeds will affect the amount of carbon dioxide in the bottle. Pause the video and resume when you're ready. Now I'm going to add about 25 milliliters of chilled germinating seeds to the bottle. To make this easier, I think I'll pour these in a cup first and then pour them in the bottle. Get in there. One last stubborn bean for science. It's that same bean. Okay, I'm going to make sure that I don't get the sensor wet, and I'm setting up horizontally. And now we will collect data for 5 minutes. Now I'm going to show all 3 runs. Record the initial and final carbon dioxide concentration in the table like the other 2 runs. For the analysis, you will need to calculate the rate of change in carbon dioxide concentration over time for all 3 runs. Knowing the rate of carbon dioxide change will help you make comparisons between the respiration rate of dormant seeds and germinating seeds at different temperatures. The analysis questions will help you think through the reasons why there are differences in the respiration rates of seeds in different conditions. Speaking of different conditions, I bet you can think of more variables to change and explore for this investigation. Think about what it's like to be a seed in the great outdoors. What happens if it's too hot, too cold, there's too much rain, not enough rain, or acid rain? These are just a few things this little seed might have to deal with if it's going to be successful at moving carbon, oxygen, and energy through the environment to you and me. So thank a seed for your next meal, and good luck with your lab.